Okay, and we are live already. Okay, so we're going to talk briefly about how we find the 5 key data points that you need to make a box plot. We're going to create box plots. This third objective actually is covered on the next note, so we'll skip to those notes at that point. Okay, so parts of a box and whisker plot. This is your box. These are your whiskers. And this is another whisker. This should all start to come back to you. At the end, on either side, are the extremes of the box plot. So this one is called your lower extreme. Do you remember that?
Yeah.
The lower extreme is just the smallest value in your set of data. So when you look at a box plot, you can look at the lower extreme and say, oh, that was the smallest value in the data. The upper whisker is your upper extreme. That's going to be the highest number in your data. Next thing I want to talk about is the middle. This line in the middle is the median. So when you see a line in the middle of your box plot, you know that represents the middle number in your set of data. So this is the median. And then each side of the box plot has a name. This is called the lower quartile. And we'll look at that in a minute. The lower quartile is just, if we have a median, that's the middle. The middle cuts our data into 2 halves, the bottom half and the top half. If we take the bottom half of our data and we find the median of the bottom half, that's the lower quartile. If we take the upper half of our data, that's the upper quartile. The other thing that you should know about a box plot is that it's cut into 4 parts. Each part is 1/4 of the data, or 25% of the data. So this whisker contains 25% of the data. This bottom half of the box is another 25%. The top half is another 25%. And this is 25%. So if we added them all together, we have 100% of the data. A box plot is really good for looking at how much variability is in the data. If the box plot is really long, that means the data is really spread out, and there's a lot of variability. If the box plot is really small and narrow, it means that there's not a lot of variability. The values are all pretty close together. We've already talked about what the range is. There's something else called the interquartile range, and I think some of you asked me what this was, so you've seen this before. The interquartile range has a little nickname or abbreviation, the IQR. The interquartile range is just the difference between the upper quartile and the lower quartile. So this region from here to here is the IQR. So it's just like how much space the box takes up. So the interquartile range is the difference between the upper and lower quartiles. By the way, this would be a good time to tell you while I'm thinking of this in my brain. When we do the test on data, which is going to be next Monday, like as in the next Monday coming up, so the Monday after Easter, I am going to allow you to use your notes. And the reason is because we're rushing through this. We're not going to have a lot of time to review. So just make sure you're taking good notes and that you don't lose any of them, because it will be an open notebook test. Yes? No, PSSAs are not until the 24th. So we will.
This was the 14th.
No, today, the Monday I'm talking about that you will have your test is the 17th. PSSAs are on the 24th, so they're 1 week later. Okay, that's our background information. Now we get into how to make a box and whisker plot. So here's our data set. Here's our numbers. The first thing you need to do is, if the numbers are not in numerical order already, you need to put them in numerical order. So you need to start with your smallest number, which is 11, and write your list of numbers. I'm just going to do this quickly. 13, 14, 15, 16, 20, 22, 25. When I write numbers in order, I always cross them off as I go. I just have a list already on my notes, but I will do 11, As I write each one down, I will cross it off. There's the 14, 15, 16, 20, 22, 25. And then just to double check, especially if it's a long list, I count how many numbers I wrote down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and I count how many were up there because that's the most common mistake is people will just forget to write one down, and so you have to make sure you got them all. Okay, next thing we do is we decide what the key data points are. So my lower extreme is my smallest number. Nathan, what is that? 11. My upper extreme is my largest number. David, what's that? David's not here. Oh my gosh, Brian, you're sitting in David's seat and I called you David without looking at you.
25.
25? I know, I'll get it later. All right. Median is the middle number. So what's the median of this set of data? Madison? 15. If we go from the outside, we cross off numbers as we go. Actually, yeah, we end up with 15 as our middle number. So our median is 15. Now, to find the lower quartile, what you do is you take just the bottom half of the data. So this 15 cut the data in half. I'm not going to use the 15 in either half, so I'm just going to forget that the 15 is there for right now. If it had two numbers in the middle and you had to divide them by 2 to get the median, you would use whatever number goes with what side. So I'm just going to use these numbers now, just the lower half of the data. What would the median of these 4 numbers be? Kayla?
12.5.
12.5. We have to take the number that's in between 12 and 13. That's the lower quartile. Now I'm going to look at the top set of data. What is the median of those top 4 numbers? Bryant?
21.
21. We need the number in between 20 and 22, which is 21. Does that make sense? How to find the lower and upper quartile? Did you guys learn that last year? Okay. Okay, good. All right, now we plot the points and draw the box and whiskers. So our lower extreme and upper extreme each get a point. So I'm going to put a point at 11 and a point at 25. The median is at 15, so I draw a line. The lower quartile is 12.5. The upper quartile is 21. Now I connect my lines with a box. And I draw my whiskers. Okay, that is all we're going to do on the first set of notes. The next one is one for you to try. We're not going to do that right now. If you don't remember this well from last year, it might be a good idea to try it later and have me check it. So switch over to the next set of notes, which is, I think it says Unit 6, Lesson 6. That's what it should say. Does everybody else in your row have a second set?
Yeah, everybody else in our row has a second set.
Only if it's an emergency, when you're using up an emergency. There you go. Wait, that's the wrong one, I'm sorry. I don't think that's it. It's this one that you need. Right. Okay. Okay, so in this set of notes, which I think I'm going to rework, shh, guys don't talk. I think I'm going to rework this for the future and just have this be one set for the accelerated class. But our objectives, we're just going to interpret and compare box plots. So someone will have already made the box plots and we're just going to talk intelligently about the box plots. Okay, so our first objective is just starting with a single box plot. When we're comparing, we'll have more than one, but first we'll just look at one at a time. So the first thing we're going to do before we start to talk about it is look at the box plot and write down what these 5 key data points are just by looking at the box plot. So what is our lower extreme according to this box plot? Megan? Good, 17. What's our lower quartile? Kayla? 18. Lower quartile is right here. It falls at 18. How about the median? Anna?
20.
20. Good. How about the upper quartile? Anna? Why did I just call you Emma. Oh my gosh, I'm
Hey,
gonna run
that's
out of
a
candy.
lollipop.
I know, it is. Don't let me forget.
Wait, you and me too.
22.
Brian has a lollipop.
Okay, and then the upper extreme. What do you think the upper extreme is? Bryant?
23 and 1/6.
Okay, 23 and 1/6. That'll work. Let's round that. That would be 23.16 repeating, so let's just round it to 23.2. Okay, the range is just the difference between the biggest and the lowest number. So what would the range be? How far is it from the bottom of the box plot to the top? Or the left to the right, I guess in this case. Angelina?
4.
Well, 4 would be our interquartile range. So if we look at the distance from the end of the box to the beginning of the box, that would be 4. So our interquartile range is 4. Our regular range is going from here to here. So we want to take the 23.2 minus 17. Anna?
6.2.
About 6.2. Good. Now, these are the kinds of questions that may be asked. What percent of the data is between 18 and 22? So what percent of the data, think about what we wrote as far as percents on that first page of notes. What percent would lie in the box? Kayla? 50%. Good. Remember that each section is 25%. So this first section is 25%. This is 25%. Another 25%. And another. The box includes 2 sections, each of which is 25%. 25 plus 25 is 50. So 50% of the data is between those 2 numbers. Number 2 says 75% of the data is less than or equal to what number? So think about if we have 75% of the data, how many sections do we have? How many sections do we need? 3. Good. We need 3 sections to make 75%. What number would we have to start at to say that there are 3 sections below that number? Bryant?
17 go to 22.
Okay, so from 17 to 22, that would be 75% of the data. So we would say that it's less than or equal to the number 22. Because we couldn't say this number is 100% would be less than that.
Thank you.
Now, number 3 says, which half of the data has more variability? So if I cut this in half, right here at the median, which side has more variability than the other side? The upper half or the lower half? Megan? The upper half has just a little bit more, not much more. It goes from 20 to 23.2, so the upper half has a range of 3.2, whereas the bottom just has a range of 3. So the upper half has slightly more variability. It's just a little bit more spread out than the bottom half. Okay, then it asks, what number represents the 25th percentile? Any guesses as to what that would be? And then I'll talk a little more about that. Michael? 18. Excellent. 18 is the 25th percentile. This would be the 25th percentile. 20 would be the, what percentile do you think?
50th.
The 50th. 22 would be the 75th.
Oh, I
And
knew
this would be the
that.
100th. Okay? So, what do we say? 18 represents the 25th percentile. Okay, now we're going to look at an example where we compare 2 box plots. So these box plots are both drawn on the same number line, which is a very useful thing because we can easily compare the 2. We have Australian Terriers and Boston Terriers. Not sure I know what an Australian Terrier looks like, but I know Boston Terriers are those little black and white ones that are really cute. They have a lot of, my daughter has a pair of pajamas that have little Boston Terriers on them, but I don't know what an Australian Terrier looks like. So someone should look that up and tell me that later. All right, this first question says, which dog is more likely to have a higher weight? So if we look at the box plot, which dog is more likely to have a higher weight? Nathan?
Boston Terrier.
The Boston Terrier. The Boston Terrier, most of the Boston Terrier's box plot is higher than most of the Australian Terriers. So the Boston Terrier. And then it says compare the variability in the weight of the dogs. Is one of the box plots more spread out than the other one? Let's take a look at what the range for each is. The range of the Boston Terrier is how much?
9 to 16.
Okay, so how far is that?
7.
Let's see. The Boston Terrier goes
Oh,
from.
no, I meant.
Oh, you were doing the Australian. Okay. So the Australian Terrier has a range of 7. What about the Boston Terrier? What's the range of that? Go ahead, Nathan.
Would you count that as 14 or 15?
I would count it as 14.5.
Alright, 7.5.
7.5. Whoops, wait. 7.5, and this one is just 7. We could also look at the interquartile range. The interquartile range is actually the same for each. So I would probably say, since there's not a big difference, I might say that there's slightly more variability for Boston Terriers, but really the variability is about the same. You wouldn't say it is the same, but you could say it's about the same, and it would be close. So you could say it's about, just make sure you have that word in there, about the same. Okay, next question asks, is the median weight for Boston Terriers greater than the weight of all Australian Terriers? So you have to make sure you read the words carefully. Is the median weight for Boston Terriers greater than the weight of all Australian Terriers? Right?
No.
No? Okay, well let's look at why. So the median weight of Boston Terriers is 19. Is that greater than the weight of all Australian Terriers?
No.
Which Australian Terrier has a weight as big as 19?
Wait, you're confusing me.
What's the greatest weight an Australian Terrier could be according to the box plot?
16.
16. 19 is bigger than that, right? So there's no Australian Terrier that's going to be that big, according to our box plot. So the answer to this, it says, is the median weight for Boston Terriers greater than the weight of all Australian Terriers? Yes, the number 19 is greater than all the numbers for Australian Terriers. So we would say yes. Okay, last question says a dog weighs 15 pounds. Is it a Boston Terrier? Is it an Australian Terrier? Could it be either, or could it be neither? Megan, what do you think? What's that? It could be either. If we look at a 15-pound dog, we could have some large Australian Terriers that weigh 15 pounds. We could have some small Boston Terriers that weigh 15 pounds. So we would say either. Okay, stop the recording here.
Oh, yeah, we got